Most people see road construction as noise, dust, and heavy trucks. But behind every road you travel on is a story of science, engineering, and advanced technology. Today, I'll show you how a simple road project actually begins long before any machine arrives. From drone mapping to CAD design to soil testing, all the way to AI-guided machines, this road is not just being built. It's being engineered with precision. Welcome to the science and technology behind modern road construction. One, CAD and digital design, the start of everything. Before any gravel is dumped or concrete is poured, a road starts its life inside a computer. Engineers create a digital version of the entire road using CAD software, GIS tools, and drone-generated maps. Inside CAD, they design the alignment of the road, the curves, the slopes, the lane widths, and even the drainage system. Every angle, every elevation, every cut and fill calculation is modeled with mathematical precision. This digital road is what we call a digital twin, a complete virtual model long before construction happens. Science involved: geometry for curves, physics for vehicle safety, hydrology for drainage. Technology involved: CAD modeling, GIS mapping, remote sensing data, and drone ortho photos. So the next time you see a road being built, remember, it began on a computer screen, designed with exact measurements that guide the entire project. 2. Materials science, building a road that lasts. Once the design is ready, materials scientists step in. They analyze what the road should be made of. Not all roads use the same asphalt or concrete. Using chemistry and physics, experts test asphalt temperature behavior, concrete strength, soil, aggregate mixtures, additives to resist heat and moisture. This ensures the road can survive heavy rain, high temperatures, and thousands of vehicles every day. Every material used on the road is a result of laboratory testing and scientific standards, not guesswork. 3. Geotechnical engineering, studying the ground. Next comes geotechnical engineering, the science of understanding the ground itself. Even a perfect design will fail if the soil underneath cannot support it. Engineers conduct soil density tests, moisture content analysis, bearing capacity tests, compaction trials. These tests ensure that the foundation will hold, that the road won't easily sink, crack, or deform. Think of it as checking the health of the soil before the road places its weight onto it. 4. Surveying, GPS, and drone mapping. After the soil checks, surveyors verify the actual land using real-time tools. This is where technology truly shines. With GPS/RTK systems, total stations, and drone mapping, engineers confirm the exact position of the future road. Drones create orthomosaic maps and 3D terrain models that help planners understand slopes, elevation differences, and environmental obstacles. This step ensures that the digital CAD design perfectly matches the real world. A few centimeters of error can cause flooding, uneven pavements, and structural problems. That's why precision matters. 5. AI-assisted machines and automation, 445 to 545. When the physical work begins, modern machinery guided by technology takes over. You may notice graders and excavators that move with surprising accuracy. Many of them are assisted by GPS-controlled systems, laser alignment sensors, temperature sensors on asphalt pavers, smart compactors with vibration feedback. These machines follow the CAD layout uploaded into their onboard computers. They know exactly how high or low to cut the soil, where to place gravel, and how much compaction is needed. It's like the road is being carved using digital instructions. Engineering meets automation. 6. Environmental science and Google Earth Engine. Modern road construction also respects the environment. Using Google Earth Engine and remote sensing data, engineers analyze rainfall patterns, flood risks, land cover changes, and erosion susceptibility. This helps planners design proper drainage, slope protection, flood-resilient structures, minimal environmental disturbance. Science ensures the road can survive extreme weather and blend responsibly with the surrounding ecosystem. 7. Smart road technology. Some new roads even integrate smart features like traffic sensors, IoT lighting, pavement temperature monitoring, structural health sensors. These allow maintenance teams to detect issues before they become major problems. Technology doesn't just build the road, it helps the road think. So the next time you pass by an ongoing road construction, remember, it's more than just heavy machinery and loud engines. It's the result of science, engineering, data, and technology working together, from the digital plan to the real pavement beneath your wheels. This is the hidden world behind every road we travel.